When to Refactor with Christian Clausen.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure Way methodology. And first announcement, my architecture forums are going strong. Signups for the next session are up, and if you lead a software team and are looking to collaborate with peer lead architects, then sign up at the link in the show notes. And also, if you are looking for the Programming Palermo video podcast, just search for it in any directory, any of the podcast directories, or on YouTube, and you'll be able to find it. So our guest today on the show is Christian Clausen, and he works as a Technical Agile Coach, teaching teams how to properly refactor their code. Previously, he worked as a software engineer on the Coccinelle semantic patching project, an automated refactoring tool, and he has an MSc in computer science and 5 years experience teaching software quality at a university level. He is the author of the book 5 Lines of Code, published by Manning. He is a top 3 rated speaker at the GOTO conference, and people standing in line to get a signed copy of his book 5 Lines of Code happened at GOTO 2022. So, Christian, welcome to the show. How are you, sir?
Hello. Thank you for having me. I'm good.
Oh, my pleasure. My pleasure. Now, it's always exciting to write a book, and I think, a little over a year ago, or maybe a little bit more than that, you put a book out. But before we talk about that, for people who have not heard you speak at the GOTO conference, would you mind giving us a little bit of the high points about your background and what kind of things led up to, thinking, I'm going to write a book about refactoring?
Sure. Yeah, of course. So I've been coding for a really long time. I started when I was a kid because it was something I did with my dad. And then I had this, I really like aesthetic stuff with the code. I wanted to make it perfect and I wanted to make it great. And I've always been more interested in sort of the perfect in the sense of easy to maintain, not having errors and stuff, being very resilient in the code itself. And so I spent a lot of time sort of thinking about that, and I started to see the world in sort of code. When you do it for so many years, and you grow up with it, that's how you see the world. I understand the world in code. And so I thought I could take on any code base and make it just perfect, right? I was youthful and idealistic, and everything was easy back then. Eventually, though, I started, after going to university and stuff, I hit the industry. And in the beginning, I got small customers, small projects as a consultant, and I could manage them on my own. But eventually, of course, the code bases grew too large for one person to go in and fix. Like when you get a million lines of code that are just a complete mess, it's not for one person to fix. So that's when I sort of shifted my focus, and I started thinking, okay, well, if one person can't do this, then maybe if I can get the whole team to do what I would do, then sort of I could still do the same improvements, or I could still get the same result. And so I started working with people primarily, and working with how to coach them, how to teach them these same techniques, or how to make the techniques more accessible. Because I'd spent, let's say, at least 2 or 3 years during my master's thesis to study like high quality software and what makes great refactoring and stuff. But I can't expect people in the industry to sit down and spend that much effort. That's just not feasible. So instead, I would try to find ways to sort of fake the understanding that I had, this deep understanding, and make it easily accessible through easy to remember rules. And it's these rules that the book is now built on, the first of which gave the title to the book, 5 Lines of Code.
Nice. Yeah, when you think about 5 lines of code, you're thinking, oh, what can you do to refactor 5 lines of code? I like the title. So what is your thinking? Because I think all the listeners have maybe inherited a piece of software, or maybe they're just going back to some software that they wrote earlier, before they learned to keep their files small, their methods small. What is your way of thinking when you inherit a piece of software and you're just trying to sort through where all this code should go?
First of all, I think my approach is quite different to what most people should do, maybe even what I should do, but it's because I'm so comfortable working with legacy code now that I can skip a lot of steps and I can take sort of shortcuts and stuff, and I can keep a lot of the model in my head at once. So I can go pretty fast and still be safe. I also worked in provable correctness. So I know what is safe to do with code and what is unsafe. And I know myself very well. So I have very good habits. Like Ken Beck also says, I'm an average programmer with good habits. For what a typical person should do though, I think is, as I said in the book, the rules are really there to help facilitate learning refactoring and getting the understanding or building it. So they're mostly meant for when you're beginning and you're not an expert yet, right? You don't have that sixth sense of what good code is and what makes it clean and what's a code smell and stuff like that. So if you have nowhere else to turn and you're just getting a code base for the first time, then I would say get every method down to 5 lines of code is the best place to start, because it forces you to learn more advanced techniques. You can't just, in the beginning, you can extract method and stuff. That's fine. That's helpful. You can put in more names sort of instead of the comments that are probably missing or misleading or whatever. You put in more methods and stuff, but then you hit this if statement, right? That's 6 lines or 7 lines, something like that. And you actually have to go in and use more powerful refactoring techniques, sort of like turn type codes into classes and stuff to get that down to the 5 lines, which is sort of it's the driver of the more advanced refactorings that are more helpful.
So your premise is that every method should get down to no more than 5 lines of code.
Unless you know better, then that's the rule, yeah.
Okay.
I'm not religious about it. It's not like something that I always do. It's if you're doing something in 2D, then 5 lines is perfect. If you're doing something in 3D, you have to break up in the middle of the for loops, which is dumb. You shouldn't do that. So then it's 6 lines. So it's flexible in practice,
Gotcha.
But if you got nothing else, then that's a good goal to aim for.
Got it. Okay. And you're mentioning these rules. Can you take us through the rules, or at least the most important ones?
There are quite a few. Well, I think the most important one is the 5 lines one, because it actually motivates pretty much everything else in the book. I also have, so the 5 lines one build up, it has some supporting rules where it's like, okay, when it's not obvious where to break it, sometimes the programmer puts in blank lines. That's a good place to break a method usually. Obviously verify that the sections are still sections and haven't bleeded into each other or faded together. But often it means that the original author of the code intended for a break to be there. And then you can put in a method. So that's sort of simple. Then you get to the if that you can't break up. Here we have a rule that says you can't have an if with an else because that's a type code. And so you have to replace the type code with classes. And that spawns a set of other rules that you can follow on after doing that. And then sort of the first 4 chapters of the book go through this big example and sort of apply more and more advanced rules to the same example, right? So it's one running example. And it built up sort of the way that I see it, the statements guide where the method should be through the 5 lines rule. And then the methods guide where the classes should be through a rule saying you can't have common affixes. So if you have draw player and update player, then you should have a player class with a draw and an update method, sort of like that. And then you can take that further, right? The classes will define where the packages should be, and sort of the whole thing just falls into place in this beautiful hierarchical structure out of nothing. It's beautiful.
Okay. And looking at the table of contents, one of your chapters is collaborate with the compiler. What does that mean?
Yes. Yeah, it's one of the things that makes my book very different from the established literature on the topic of refactoring, is that everybody else, it goes into a lot of detail on testing. They say they speak as if testing is the only way that you can safely refactor code. Unfortunately, I like testing. It's a great tool if you get it to work. Unfortunately, in my experience going out helping teams, not a lot of teams have test coverage at all, or any sense of testing. They don't know where to start. And if I have to teach them first how to write tests and then how to refactor the code, it's a huge endeavor, right? It's a multi-year project for a decently sized organization. And we don't have that time. We need to get the code in a better state now. Usually also you have the problem that poorly designed code is also harder to test. So which to do first, the testing that's hard or the refactoring that's impossible? Without the testing, it's sort of, you get stuck in the chicken or the egg situation. And so what I did is I said, we don't need testing to be able to do refactoring. If we're working without testing, we've already accepted there's some risk in that area. That's obviously an acceptable risk to us because we work with it every day. Then there are still some things we can do safely with the code if we rely on other tools then to sort of catch us when we go wrong. I rely very heavily on the compiler from my experience with, as I said, provable correctness and type checking and stuff like that. So I use the type checker in all of my refactoring patterns or in all of my formulations of the standard refactoring patterns. We sort of rely on what I call safe operations. That is things that the type checker will check if we do it wrong, or copy and paste is very common because it's very difficult to break code with copying and pasting unless you're deliberately trying to. So stuff like that, I rely much more on what the compiler can do.
Okay. And earlier you did mention comments or misleading comments, but there's a chapter in your book that flat out says stay away from comments.
Yes, and I have 5 categories of comments that I've identified, and it's something like, I call them outdated as the first and the worst kind, and that's also being sort of kind because it implies that they have been correct at some point. I have seen comments in the wild that are just flat out wrong. They're not doing what the comment is or what the code is doing, or they're saying something like. And these, not only do they take time to read, I still need to understand the code. Or if I follow them blindly, I'll do something wrong. I'll break something, right? They're deliberately making bugs more likely. So whenever people ask me if they should do this or this to their code, it's the same discussion with if they should use like sort of LINQ when it came out and like advanced features of the programming language. I'm like, listen, is it helping you not make bugs or is it helping you make more bugs? Because stay away from one of those, right? So we have outdated comments. We have comments that are just out-commented code. If you're using version control, which you should be in a professional setting, there's no reason to comment out code, or at least not committed code, right? You can have it on your checked out branch while you're doing something, but don't check it into the main branch. Then we get to like the trivial comments where they're saying the exact same thing that the code is saying, which is pointless. The code is already saying it. The 4th category, I think, is things that should have been a method name. Sometimes you have like a header for a section. I think they're also called, where it's like, well, this code logs an error. You could just have a function that says log error, and then it becomes a trivial comment and you can delete it. The final one, and the only one I actually want to keep, is documenting a non-local invariant, something that I can't see on my screen, but I need to remember if I'm going to touch this code. Those can stay. Those are really important, but they're also fairly rare.
Okay. Now, in refactoring, one of the really risky things just in general is modifying code that we don't understand. I'm speaking for myself as well. And one of the other points that you make is changing code by addition rather than modification. And that right there, wait a minute, I need to change this code. What's that thought process? How do you teach that to your clients?
Yeah, so depending on which era or paradigm they're coming from, it's actually really interesting. But what you can do is, when you have to change some code, you can encapsulate that in sort of a method at least, or maybe even like more stuff like that. If you have it in a method, you can just wrap that method in a class and then just instantiate the class where you'd call the method and then still call the method, right? You have the same code running. All of these are very safe operations. But then if you have that, you could also just, instead having the class implement an interface, right? You extract the interface from the implementation. And then you can make another class that implement the same interface with the new code that you have. So that way you haven't modified the original code at all. You've moved it around a little bit, but it hasn't changed. But you've added some new code that you can now inject in that location in the code. I think I call it an extension point or something like that, where you can have variations being called. It's sort of a backwards way of looking at strategy pattern. A lot of people that I've seen teach strategy pattern, which is immensely powerful. They teach it sort of from a foresight point of view, where it's like, oh, I know I'm going to need a strategy pattern here. Or like, I can see in the UML diagram of this application that I'm going to need a strategy pattern. And I'm like, I don't have that foresight usually. It's a very difficult thing to sort of be in that situation is unlikely. So instead I say, well, write the code the first time, just the full method as you want it, then copy the entire method, then modify it all that you want because it's copied, right? It's not the original. So you can make any modifications. And then once you're done, you look what from these methods is still similar and what is different. And then you put all the different stuff in an interface or in a class. And then or in two classes, if you have two methods, with a common interface. And then you have one method at the end. They're completely unified. And I view that as a much more natural way to think about strategy pattern, as a way of unifying two methods that started out being the same, but then they went their separate ways and you can join them together again.
Yeah, interesting. Now, I always have to recognize our industry has grown massively. I think the stats that I've seen show that that half of the developers out there writing code joined the industry about 7 years ago. We've doubled in the last 7 years. And so,
yeah, sort of Moore's law for software developers.
Right. And so there's so many listeners out there who are desperately thinking, okay, I need to Google what strategy pattern is. And besides the official definition, what's your best quick summary of what the heck strategy is?
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Well, yeah, I mean, the best summary would be very similar to the one I just gave. It would be it's a method. It's a way that you can copy some code and then unify it back together once you've worked with it. It's sort of the last step in the duplicate, transform, combine again, something like that. Again, if you don't have testing, right, as I said, one of the things you can do safely is just copying some code. So you have two copies and then you can destroy one of them without it affecting anything else. So I think a lot in coupling like that. The strategy pattern is just a way to unify two pieces of code.
Okay. Earlier, you mentioned a term called type code. And I think a lot of people are not familiar with just that term, type code. Can you kind of give us an overview of what that is and how we should be thinking about those?
Sure. I think it's a very old term. At least it's not one that I've heard in any other context than the one I use it in.
I think you're right. It's just people don't use it as much as they should probably.
No, or at least recognize that they're working with type codes. So the way that I use it is type code is anything that you can sort of distinguish between the values of. So an integer, an enum, a string could be it. If you have a finite set of strings, that would be a type code. Booleans are type codes. Anything where you can say it's this value or this value or. So you have a finite set. A floating point would not be a type code unless, again, you have a finite set of floating point numbers you use. So it's just something that you can write down in a set and then characterize.
Because a floating point has almost an infinite number of possible values?
It's very rare that you would say, do something similar to a switch on a floating point. I don't even know if you're allowed to in any languages, but you could do a chained if else, but that's still very weird where you'd say if it's exactly this value or it's exactly this value. It sounds, that's the behavior of a type code, or the characteristic of a type code is you have either an if else chain with equals or you have a switch.
Right. Now you don't like the else keyword, right?
Not the switch either.
Right. So tell us your thinking on that.
So switch was like an original code smell already back in Martin Fowler's book back in 99, I think. The thing is, it pulls context towards it. It sucks in the context, right? So that all of the invariants that are tied to the data that you have sort of if you imagine having an enum for something like, what color is the traffic light? And then you know something about, well, if it's green, then I know these things can, the others are red, and some of these people can drive or walk or whatever it is. If you have a switch on the traffic light, then you'd sort of pull in all of that context to the switch instead of having it out at the data site, so that green knows that it can now tell people to walk or stuff, drive, whatever. You'd pull it in and say, well, cars make a decision, so they pull in something from the traffic light, and pedestrians make a decision, they pull something in from the traffic light. So you point the arrows away from the data, sort of in a flow kind of way. I know it's getting a little bit abstract. The same happens when you do if-else chains. They're the same as switches. They're just slightly more powerful, but they're still doing that. They're still pulling the context to the checking point. Whereas instead, I like to push all of my decisions out to where the data lives. So if you have to work on some data, I want it to be entirely encapsulated, which means the code has to be right next to the data. That also helps me localize invariants, which really is the whole power of my approach to refactoring. I sort of say, I don't concern myself much with good naming and stuff because it's a late stage refactoring thing. The first thing I need to do is localize my invariant so that the code is safe to work with, even without understanding it. And so the invariants, like, where do the invariants point? Do they point away from the data or towards the data? If it's towards, then it's easy to keep in your head. You have it in one file, I can sort of read through it and then I know everything. Whereas if all the invariants are being pulled out all across the code base, I have to now build a model that encompasses all of these different areas in my head at once to make any modification, right? Because I might break something somewhere else if I haven't spotted where that invariant flows.
So in doing this, it's almost like you are improving the object-oriented structure of the code itself.
Yeah, very much. It's very, very centered on object orientation, what I've done. It's utilizing objects all over the place, but it's because of the flow of invariants is really the central thing.
Interesting. You mentioned the data multiple times. One of your chapters is Defend the Data.
Yes, where we talk about encapsulation for the first time, because everything else has been sort of on method level. That's where we move up and go, or we've introduced classes, but we've mostly pushed around code. In Defend the Data, we start talking about the classes and class design and push versus pull-based architecture, where you often see that people make all these data classes that are basically just dumb classes holding integers and strings and stuff. And then you have manager classes or calculator classes or stuff like that, with the common postfixes that we all know and love, where then the manager pulls in all this data from 6 different objects, and then it does a little bit of calculation, and then it sends the result back to someone else or whatever. And it's like, you have to expose all of that data, and all of those invariants are now mixed in a big jumbled mess right there in like a big knot. And you can never sort of untie that if you keep that manager class around. So really, I would much rather sort of split the calculation into 6 partial calculations and then push them out, one on each object, where it augments the sort of intermediate result with whatever data it has at this moment. So you sort of think, well, I view this code as having 6 sections instead. So I'll split it up first into 6 methods, and then I would push each of those methods into the appropriate class so that I can make the data private, and the fields should never be exposed, right? That way, the control flow happens on the method level instead of on the sort of the data pulled everywhere.
Okay. Now, one of the sections that some people may find surprising is you have a rule: do not use getters or setters. Now, where are you strongest in that advice?
Well, the thing is, it's the same point, right? It's the thing that in a pull-based architecture where the manager classes or whatever you call them pull in data towards them, then you will have either public fields or, let's call them, sort of feel-good public fields where you have getters and setters. They're still public, so it's like you haven't really improved anything. And I remember when I learned about encapsulation back at university, first I was like, I have to make everything private. How am I going to calculate anything? I can't access any of the data. And then they said, you could just use getters and setters. I'm like, why am I making them private then? It's literally the same thing. I could just have them public. because people, it's not like the getters and setters stick around, right? It's not like you've added an extra level of abstraction so you can change the field. Whenever you change the field, you change the getters and setters also, and you change everything in the code base. So it's like, there's really no point to this. They're still tightly coupled to each other, right? That's really the technical term for the issue there. So if you're using getters and setters, you might as well just have it be public, and that's bad in itself because you're coupling now different places together and you're spreading the invariance across the code base. So if you can't have public fields and everything has to be private and encapsulated, you can't have getters and setters. Luckily, they're fairly easy to remove because when you make a getter or setter private, it will error all across the code base when you run the compiler, hopefully.
Yep.
Unless you're using reflection or something crazy like that. But then it'll error everywhere. You can just go to those places, extract the parts that are erroring into their own method, and then push that method into the class with the data. And then, you'll just have collected all of the invariants automatically or in a very systematic way. And then you run into as I mentioned before, the common affixes, because after pulling out all these methods, you'll have a lot of methods. But then the chance that you'll have two with the same prefix or suffix are a lot higher. And that means you should probably extract another class from that, right? And then encapsulate even more data. And that's sort of the flow of this style, refactoring.
Now, with no getters and setters, are you also talking about entity classes that hold data that maybe persisted to a database table? Or are you not talking about those types of classes?
That's an important question. And there is a chapter that I didn't have in the book because I hadn't thought about it deeply enough at the time of writing, but that I'm mentioning every time I talk about the book anyway, so I should have just put it in the book. I use a mental model that I call the spaceship architecture, where each service, let's say something that's deployable, has like a core pristine part where we have control of all of the data types. We only use data types that we control. So everything is mapped, everything is nice. Then every time you want to talk to something outside of that spaceship, you have to go through an airlock, which is like in the old school way, we'd call it an adapter class, something like that just maps from foreign classes to our classes that we can push code into, because the whole thing relies on pushing code closer to the data. And so if we have something coming from the database, I would map it quickly to something that we control. Also, I would do that manually. People always like, oh, don't you use a tool for that? Don't you do this? Or,
sure.
Like, I'm not lazy. It's easy to do. It takes you at most an hour. Just do it, right? Get over it. And then, you have these classes that you have control over. So you can still break the rules in an airlock so long as it's... I also have packages actually called like airlock this, airlock that. So I know that here I can't rely on the rules because you can't do that with database classes and stuff like that, right? You need... Some classes have built-in features that you need.
So all the object oriented or the object relational mappers, they kind of expect, like if you have a customer class, they kind of expect you to have get and set getters and setters so that you can save it to a database table. So are you saying that you would have ORM classes kind of outside your airlock?
Yes, or in the airlock, I guess, because then just not in the pristine part, just not in the part where I follow all of the rules and have all this really nice code. And then I would have some nice interface to actually work with them in the airlock that makes it seem like it all is nice, but it isn't underneath.
And is that the same thing in the user interface? If you have a screen where we need to update some information about the customer and update the phone number or address, the UI, those controls, typically we call a getter, use a setter just for that. How's your thinking on that user interface
exactly the
part?
same. You have an airlock between the UI and the pristine part of the code that just maps from whatever the UI interacts with to whatever I can actually work with efficiently. It's sort of like every problem in computer science can be solved by another layer of indirection, right? Is the famous saying. That's just what I'm trying to do here. I just want to have one part of the code where everything's perfect, and then I have all this messy stuff around it, so long as I tag it as messy in some way. I use the package, right? I just have to know where I can rely on these things and where I can't. It's all about simplifying the mental model for people.
Gotcha. Would there by any chance be a public Git repository with a sample or two of code that follows all the rules outlined in the book? Or what if listeners are saying, okay, what does this look like? Where can they look at anything?
So the book has actually comes with the 2 project repositories, so to speak. One of them is the one that I treat in the book. It's a small 2D game. And you can go in and see it actually has a commit for each thing that it does, that I do in the book. So you can see each step, even if you want to. But you can also go and just look up I think the branch is called solution or something, to see the final product of following all of the book through to the end of the book. As I also say in the book, more can still be done. It's not like this is final. It's just, this is a really good jumping off point, and there's nothing really to teach anymore. It's just a little more continuing that thing. Also, as I say often, refactoring relies on predicting the future. Refactoring is a way of making the code more susceptible to some type of change that you expect to come in the future. And the way that it's all described and talked about is we expect similar changes to the ones we've already had. And so we're making the code more susceptible to the type of changes that we're used to. And that's generally, it's good. It's not always the case, right? You might end up having spent 100 hours refactoring something to be perfectly suited for one type of change, and then something else happens, right? The world changes in a fundamental, or the business changes in a fundamental way, and all of your refactoring might be working against you. That's like, so when people talk about you shouldn't gold plate this and stuff, I always get a little bit annoyed, because you're missing the point of this. It's not because gold plating is bad. It's because you are taking a bet on how much do you trust that you can predict the next change, right? If it's 100%, sure, there is nothing, you can't go far enough with refactoring for that. But if there's even like a 95% chance, then you should leave refactoring at 95% done, right? Something like that. Yeah, so there's the one that I treat in the book. You can go look at the solution. There's also an advanced project for if teachers want to use it or something, where the solution isn't provided anywhere, at least not that I know. And so people have to actually find it themselves. So that just has the starting point, but it's very similar in style and stuff. There are a few sort of gotchas. You have to really pay close attention to the process. Otherwise, you're going to probably trip up. Whereas the one in the book is a little more nice to look at.
Right. And I think earlier on, you talked about going into systems with 1 million of lines of code and using these rules to actually get a better handle on it. That's the right context, right?
Yes. Yeah.
Wow.
Yeah, I've done that. But it's and it works on many scales. I've taught it to a lot of people. I discussed it with a lot of my friends when I started coming up with these rules. And after a little bit of sort of demonstration and stuff, a lot of them tried them out in their respective industries, everything from fintech to military software and everything else. You know, it's all over the place and everywhere. The first reaction was that their peers, when they were submitting pull requests, their peers would be like, "What is this? This looks super weird. I don't understand anything." And they would just say, "Oh, look at this book, or look at these. I have these cue cards and stuff. Like, look at these things." And eventually, I would always follow up a few months later, say, "Do you still do this?" And they're like, "Yeah, the whole team started doing this sort of stuff. Maybe not completely, but at least the first couple of chapters, something like that." And that's just it. And then the crucial question: are you happy with it? Is it making the code better, or are you just doing it because you like it? But I've so far only gotten good feedback. The fact of transforming type codes and stuff into powerful classes where the code is localized, it just makes it so much nicer to expand and maintain later.
Right. And I would imagine it also helps teams like that embrace collective code ownership instead of having one section be where only one programmer really understands it.
Well, the reason I don't go much into like talking about method names and stuff is that naming is really hard. It's just fundamentally hard. There's no easy way to solve that, or no good guideline that's going to always help you. It's just hard to name things. But something that is true though is that it is much easier to name 5 lines than it is to name 30. Right? Because 30 is typically doing 3 or 4, maybe 5 things, whereas 5 lines is doing sort of one thing.
Right.
So just name it that, right?
That's right. Yeah. I would imagine the naming gets a lot easier in that context.
Yeah. And then when you bubble that up to the methods where you started by extracting it, That also gets easier to name because now we have 5 methods with good names that you have to find a collective name for instead of, again, 30 lines of low-level bit shifting and stuff like that, and it's all crazy. And
Right. Awesome. Well, fantastic. Well, this is fascinating for me, even just to listen to you describe all this. Now, with the book, 5 lines of code, where is it most advantageous for people to buy the book?
I only care about the knowledge, actually. I just want to make developers' life easier. That's really all I care about. So I think I get the same cut everywhere.
Okay.
So just pick it up, read it if you like it, share it with a friend, lend out your copy, stuff like that. I just care about getting the message and the methods out there.
Awesome. Fantastic. Well, we will link to the book. And wow, thank you so much for coming on the Azure DevOps podcast and sharing with us when to refactor and your rules that you've developed for doing that. Thank you so much.
Thank you, Jeff.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.